right, welcome to high school online classes. Today we want to look at some questions that have been written so far in physics. Some of these questions that have featured in the this year 2025 Jamb UTM examinations. So we are to look at some questions which have been written in physics that actually came out. These are real questions that have been written in Jamb for this year so far. I'm doing this because it's likely that some of them might be repeated, or at least we're able to know the patterns on which the questions are being asked. Without much waste of time, let's dive in. The first one says the SI unit of pressure is dash. We have all the options here. For us to solve this problem, we need to know what pressure is. So pressure is equals to force over area, and the unit of force is Newton, and that of area is meter squared. So we can write this as Newton per meter squared, or Newton times 1 over meter squared is equivalent to m raised to the power minus 2, because in mathematics a negative index denotes a fraction. So we can actually write this as Newton per meter squared in this form, and of course the answer is C. However, let's review the other options. This option is actually a unit of moment or energy, force times distance. Joules is energy, and seconds is for time. So it's far from it. Then watt is equivalent to joules per seconds, and of course watt is for power. So the right option here is Newton per meter square. Let's go on. Question 2 says, if two forces of 5 Newton and 12 Newton act at right angles to each other, the resultant force is this. Alright, since they are at right angle, that means the angle between F1 and 2, which are 5 Newton and 12 Newtons, is 90 degrees. So we're going to be applying our vector law, which says that if you have two forces or two vectors, because force is a vector, first one is 5, the other one is 12. So the resultant is obtained by this way, following the parallelogram law of forces or vectors. So this is the resultant. Of course, to go ahead, we have to complete this in this way. This is our R. If here is 5, this is also 5. So we have our 90 here. So by applying Pythagorean rule, we know that R squared is equals to 5 squared plus 12 squared. 5 squared is 25. 12 squared is 144. So R squared is equals to 25 plus 144 is 169. And of course, R is given by the square root of 169. That is 13 Newton, which is option C. C again. All right, let's write down. So which is velocity is equals to distance over time. So now the formula that connects distance and time and velocity is that velocity is equals to distance over time. That implies that ds dt is equals to velocity. So in that case, if we integrate velocity, that is dv, integral of v dt, if we integrate velocity respect to t, we are going to obtain distance. So in that case, the area under a velocity time graph is given by distance covered by that object. And so the correct option here is option. Alright, number 4 says, a car accelerates uniformly from rest to a speed of 20 meters per second in 5 seconds. What is its acceleration? Alright, without being told, once we see that the car starts from rest, that means the initial speed of velocity is 0. So our initial velocity is u is equal to 0 meter per second, please. Now to a speed, final speed v is 2 20 meter per second in 5 seconds t. So t is equals to what? 5 seconds. So we are looking for acceleration. Acceleration A is given as final speed minus initial speed divided by the time. Our final speed was 20. Initial speed was 0 over our time is 5 seconds. Yes. So 20 minus 0 is 20, and 20 divided by 5, that is 4 meter per second squared, and that's option, yes, option A. Now number 2 says the bending of light as it passes from one medium to another is called dash. Now let's analyze this. When light passes through two different media of different densities or thickness, there is a kind of resistance caused or observed. So, and as it happens, the light direction will have to change its path because it has encountered a material of a different density as the former one it was coming from. So in that case, the path is going to bend. Let's assume that a light ray passes from this air into, let's say, glass. So at the point of incidence, we have, let's say we have a normal. So if the light is coming this way, this is air, this is glass. Now because glass is thicker than air, instead of the air, the light to keep on moving like this, no, it's going to refract, it's going to bend itself towards the normal. So there's kind of what bending towards the normal. So this phenomenon of light is called refraction of light. And that is a reason why we have some occurrences in nature. For example, in a glass of water is poured in a basin or in a glass cup. It will be as if the bottom, if the water is somewhere here, the level is somewhere here, and this is the bottom, just to be as if the bottom is somewhere raised up. Another observation is when we have if we have a piece of stick dipped inside a bowl of water, a piece of stick will appear to be broken from between the air and water interface. So the phenomenon in which light bends as it passes from one medium to another when there is difference in density is called refraction. That is option D. Now the next one says a machine has an efficiency of 80%. If the work input is 200 joules, the work output is dash. All right, let's analyze this. You're having our efficiency epsilon as 80%. They just write 80%. And we have the work input, work in, as 200 joules. We are looking for work output, work out. That's unknown. Now let's not forget that the efficiency of a system is the rate of output work to the input work. So in this case, now we have efficiency of 80 Newton, input 200 joules, and output is unknown. Now, efficiency in machines is given by work output over work input expressed as what? Percentage. In this case, we're having 80%. So we have 80%, which is 80 over 100. Work output is unknown, and work input is 200. Because I have 100 here, there's no point putting 100 here again. Or we can just, if we are having 80 this side, we have to put 100 this way. Whichever way is okay. So let's go on with this since it rhymes with this. So 0 cancels 0, 0 cancels 0. Multiplying, we have that work output is equal to 2 times 80. And of course, that will give us 160 joules. All right. The next question says, a 5 kg block is moving with velocity of 4 meters per second. what is its kinetic energy? And we have the options here. Now, let's look at what we have. We have mass. Our mass is 5 kg, and our velocity or our speed is v equals 4 meter per seconds. Now, the kinetic energy is given by Ke equals to 1 over 2 mv squared. That will give us 1 over 2. Our mass is 5. Then our v is 4. 4 squared. Now, 4 squared is equal to 16. So 2 here, 1, 2 here is 8. 8 times 5, that is 40. So that's why it's 40 joules. Now, as a revision, Ke, which kinetic energy Ke is given as half mv squared. Half mv squared. That is energy possessed by a body in motion. While potential energy, which is energy of a body by virtue of its position or its being at rest, is given by Pe equals to mgh. And don't forget, if a body goes up, the higher it goes, the lower is the kinetic energy and the higher is potential energy. So as a body goes up, kinetic energy decreases and becomes zero at maximum height, while the kinetic energy increases. While the PE increases and becomes maximum at maximum height. And the body is, if the body is coming down, potential energy will keep on decreasing, while kinetic energy will keep on increasing and becomes maximum at the lowest part. All right, let's go on. The next question says, the amount of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius is called dash. Now, we have observed when we have a liquid and a solid, let's say pepper soup, for example. You have a plate of pepper soup with some solids. Solid there can be meat and maybe some yams. While the liquid there is the soup itself. Discover that if we are to separate the meat from the liquid parts, we find out that the soup or the soup rather the solid part being the yam part gets cold easily than the watery part. That is because it takes more energy to reduce or to lower the temperature of a liquid than what it takes to lower that of a solid. So this temperature, which is this heat required to lower or to raise the temperature of a body by 1 Kelvin or by 1 Celsius, is called specific latent heat. Specific in the sense that we're talking of just 1 kg or just 1 kg. So specific latent heat, or which we can also call it what, sensible heat. I have some videos on it on my channel. So the heat required to raise or lower the temperature of 1 kg, just 1 kg of a substance by 1 Celsius is called the specific heat capacity, which is option C. The heat capacity is when we talk about the entire mass, entire mass of the substance, not just one kg. While latent heat is the heat required to change the state of the state of matter of a body. Let's say from solid to gas, from solid to liquid, like a melting. For example, when water freezes to ice, that is fusion. Now, when water now changes to vapor, that is vaporization. So the heat required to do this is called latent heat. And when we talk about just a specific latent heat, is of course when we are looking at just 1 kg, just like we have just 1 kg here, 1 kg here. So 1 kg here to raise the temperature by 1 Kelvin, 1 kg here to change the state of matter to that phase at constant temperature. Don't forget, this guy occurs with a change in temperature, while this guy occurs without any change in temperature. Let's write down. Number 9 says a 10 ohm resistor carries a current of 2 amperes. What is the power dissipated? Now we have resistors as 10 ohms. And we have current as 2 amperes. We are looking for the power. Power P is unknown. Now the power we have, the power in this concept, power is given by IV or I square R or V squared over R. But because we are given just I and R, we are going to make use of this particular formula. So we go. So power is equals to I squared R. Our I, which is current, is 2. So 2 squared is 4. And our resistance is, to avoid confusion, so 2 squared times our R is 10. So 2 squared is 4. 4 times 10 is 40. And the right option here is option B. Yes, option B. Now we go to the next one. The next one says, how long does it take a 720 watt heater to raise a temperature of 1 kg of water from 20 Celsius to 50 Celsius? If we have that the specific capacity of water is 4,200 joules per kilogram per Kelvin, and we have options 40, 20, 60, and 100. I think that is seconds. We'll find out later. The power is 720 watts, and mass is 1 kg. Initial temperature is 20. That theta 1 is 20 Celsius, while theta 2 is 50 degrees Celsius. And what again? Its specific capacity of water, CW, is equals to 4,200. Now we know that once the heater is being plugged to heat the water, the electrical energy in the heater is being converted to heat energy to raise the temperature of water. So without much waste of time, the electrical energy from heater is equals to heat energy to raise the temperature of the water. Electrical energy is given by power times time. And heat energy is given by M, mass, times C into theta 2 minus theta 1, because we are having an increase in temperature. So power is what's the power? Our power is 720 times T. Our mass is 1. Our C is 4200. Our theta 2 is 50. Our theta 1 is 20. So this will give us 4,200 times 50 minus 20. That's 30. So don't be in a rush to multiply out. Now our T is very multiplied by this 720. We get our T. 720. 0 cancel 0. And 3 in 3 is 1. 3 in 7 is 2. Remember 1. 3 in 12 is 4. So you are left with 4200 divided by 24. What can go? 3 can go, because 2 plus 4 is 3. 2 plus 4 is 6, and of course 3 can divide 6, so 3 can divide 24. Now 4 plus 2 plus 0 plus 0 is 6, therefore 3 can divide this. So 3 in 4 is 1, remainder 1. 3 in 12 is 4. 3 in 0 is 0. 3 in 0 is 0. Now 3 in 24 is 8. Is 8. Now 2 in 8. 2 in 8 is 4. 2 in 7. 2 in 14 is 7. 2 in 0 is 0. 2 in 0 is another 0. 2 here is 2. 2 here is 350. So 350 divided by 2. 2 here 1. 2 in 3 is 1. Remember 1. 2 in 15 is 7, 1. 2 in 10 is 5. 175 seconds. Fortunately, something must have gone wrong, but the correct answer is 175 seconds. I must have gotten the options wrongly from one of my students who sent this particular question to me. I advise you follow up the channels. I will be bringing out the questions that are featured in physics and of course in mathematics. This will enable you to know the style and the level of difficulty this year's question are. For you to do that, you have to subscribe to our channel for you to be able to get notified whenever we post our videos. All right, until then, thank you.